Hello, JS1 student. How are you guys doing? I want to believe you are doing great. You are doing wonderfully, and I believe in you because the one that lives in you is greater than the one in the world. So I know you can do it. You can become successful. All you need to do is believe in yourself. Now it's time for another time to have our basic technology GS1 student. Since the last week we've started a series of topic on what, on basic component of electrical circuit. I want to believe now you now have the little understanding of how current flow from one place to other in your in that your component of electric circuit. You can now describe at least, okay, current is flowing, you have your neutral, you have the earth, you have the understanding of what we mean by current, voltage, resistance. Now today we want to continue from where we stopped. Last week we started looking at capacitor. Now today we want to continue from the principle of operation of a capacitor. Now we are told that a capacitor is a device that is used to store electric charge. Take note, a capacitor is a device that is used to store electric charge. And I said that there is something that determine the efficiency of a capacitor. While we are talking about the plate of the capacitor. So here we are told that when the flat plate parallel to each other are charged either positively or negatively with electrical force, e.g. cell connected to point A and B. So what are they trying to tell us that now? That if the plate is charged due to the EMF that is flowing inside the capacitor, then this is how the principle of or the operation of a capacitor. Now the plate usually called electrode, and why the other are called, we have the positive and the negative. Now let's look at quickly on types of capacitor. Type of capacitor. The first one is air capacitor. Air capacitor. We are told that the dielectric is aided. This type of capacitor is what is commonly used in electric circuits. In electric circuit, two aluminum plates are used. One part of the aluminum is fused while the other can be tuned. That is the L capacitor. We find it in our electric cycle. We have paper capacitor. This consists of a thin sheet of paraffin wax paper rolled between the coating of the thin aluminum foil. Okay, now we have mica capacitor. These are the type of capacitor as a solid material, and it is dielectric constant. It can be used where many capacitors are required. So you have it on your set, on your radio set. You find it like a pink color like that. We have it like that. That is mica capacitor. Mica capacitor. Okay, so we have what is called electrolytic capacitor too. We have electrolytic capacitor. We are going to see the next slide. Now I want to believe now I have the four type of capacitor we are talking about here. We have the air capacitor, we have the paper capacitor, we have the mica capacitor, and we have electrolytic capacitor that in most of our radio set we can find this mica capacitor in it. The paper capacitor is what it contains like a wax paper, then is the form of rolled between the coating of a thin aluminum foil. So that is what we call your paper capacitor. And we have an air capacitor that the dielectric is aided. This type of capacitor is commonly used in our electric circuit. Two aluminum plates are used. So these are the dielectric polyethylene capacitor. Now the plates of the dielectric are rolled up to convenient size and usually enclosed in a plastic cardboard melter case. Now capacitor also classified in terms of fixed and variable capacitor. There are some capacitor that they are fixed, while there are some that are variable capacitor. Capacitor can be used in many electronic circuits, e.g. in a motor vehicle, air condition, and so on. Even you can find them in our generator. Now even the ceiling fan, the standing fan, you can find it. You can also find it in your in that the small engine that control your water pumping machine. water pumping machine. Now this variable resistor we are talking variable um, um, capacitor here. We have the fixed capacitor. Okay, so these are what we are talking about, type of capacitor. Now we want to look at transformer. Now transformer is a device that can step up or step down voltage value. They have step up transformer, we have a step down transformer, and they have a two side. You can see the primary side that is painted in form of red. You can see the secondary side that is painted in blue. Then you see that green stuff is called magnetic flux, because there is nothing like connection. There is nothing that is connecting them. It's the flux that is going to produce from the primary coil, which is called induced voltage, or induced what flux. We connect with the one of that secondary coil, then they start operating. Then we have your IP, which is for what, current in the primary. We have NP, number of turns in the primary. We have EP, EMF of primary. Also for secondary we have RX, that is the current in the secondary. NS is the number of turns in the secondary, and ES is the EMF in the what, in the secondary. Now we can see it here. The voltage in the primary is called your EP. Now number of turns in the primary is called NP, and the voltage in secondary is called ES. Number of turns in the secondary is called what, NS. Now let's look at this example. We are told that a primary winding of a transformer is 10 volts and the primary winding is 20 turns. Now if the secondary voltage is 100 turns, find the secondary voltage. Now let's try to pick out the data. Now they give us EP to be 10 volts, EP to be 10 volts, EX is unknown, which is the word, the secondary voltage we are looking for. They give us the word, the number of turns in the primary to be 20 turns, the number of turns in the secondary to be what, 100 turns. 100 turns. Now the next slide is going to show us a perfect formula at this level that you can have understanding of it. Okay, so now the first thing you need to understand, you pick out the data. So it's from there you now know, okay, which one are you looking for? Is it EP, is it ES, is it NP, is it NS, is it IP, is it IX? But in this question we are looking for what? ES, because EP is given to be 10 volts, while NS and MP is given to be 20 and 100 respectively. Okay, 100 turns respectively. So we can have that now. Now the formula for what, for using to find the transformer is your word, EP over EX is equal to NP over NS. EP is equal to what? EP is equal to EP over NS is equal to NP over NS. It's just like that. How we have it, EP over ES is equal to NP over NS. Now because we are looking for ES, so we make ES the subject of formula here. So EX is going to give us EP times NS over NP over NP. So your EX is now going to be, your EP is given to be 10 volts. Number of turns in the secondary is 100, and the number of turns in the primary is 20. So that is 100 times 10. You get your 1000 divided by 20. So your final answer is 50 volt. 50 volt. Now we are told that small transformer are used in stepping down voltage for some very low voltage household appliance. Now very large commercial transformer are used at a substation to step up from the Kanji dam to low voltage for residential use. Now when you saw where they generate power from Kanji dam, they transmit it over long distance, and due to the long distance the voltage is what tend to reduce. So what do you use? By the time you get to your substation, they step it up again from Ikeja distributing the system. So they distribute it down to the substation we have in your street. All those transformers you have in your street, then they can now step it down to 415 volt. Okay, so we have some question for you here that I want to believe you can lay your head upon. All that is going to cover all what we have done so far on what on component of electrical circuit, that capacitor is there, electrode is there, and type of scale. Okay, we are still going to do this. Okay, now state giving example of type of wood, the gap between, and yeah, you can see the next question here, capacitor and other SI unit of inductance. I want to believe yeah, inductance. Okay, theory aspect, potential difference, inductance, resistance. What is capacitor? State the type of capacitor. I want to believe we just finished this one today. So you go into your notes, go into this video. I want to believe you can have more understanding of this. Thank you for staying tuned. Thank you for this honor.